Now, this is going to be a short video. It really is going to be a continuation of section 5.2, the OpAmp voltage and currents. Now, let's see, this is what we did in the previous video. We defined the output maximum and minimum for the operational amplifier. I'm just going to do that in a graphical manner right now. Okay, here's what I'm going to do. You know what? I'm going to use the same page. Actually, I'm going to plot the output and the input on X and Y axis. Okay, on the Y axis, I'm going to write the output V out. I'm going to plot the V output voltage. Okay, I'm going to plot the V output voltage on the Y axis. You park this somewhere else. Okay, on the X axis, I'm going to show the term A times Vp minus Vn. Okay, now what I'm going to do is to simply show you these two expressions in a graph. Okay, what it means is the output maximum is going to be that guy. Okay, output maximum is going to be plus VCC. Okay, the output minimum is going to be negative VCC. Okay, negative VCC. Negative VCC is going to be the output minimum. Then in between these two values, the output is really going to have a slope. Okay, what it means is the output, this component, this region of operation shown using the expression here, this region of operation corresponds to the product of A times Vp minus Vn. Let's look at this one. This region of operation, okay, this region of operation really corresponds to the minimum output possible. Okay, similarly, the region of operation here, okay, that corresponds to plus VCC. V output maximum is plus VCC. That is what is shown in the purple color here. Now, shown in the reddish color, okay, is the negative VCC. So let me color code them. This one is called positive saturation region. Okay, the region where the output maxes out at plus VCC. Okay, that's the positive saturation region. And then this region is called negative saturation region. Okay, this is called the negative saturation region. And the region in between, this region, all of this, between the positive and negative saturation region, that is called the linear region. Okay, that's called the linear region. Let me write it in a more convenient place, linear region. Okay, everybody with me? So there are three regions of operation. You always want to make sure that your op-amp, you know what, let me drag all of this to the next page so it's easier to see. Okay, on the x-axis is your Vp minus Vn times A. Okay, as the difference between your input increases along the x-axis, your output keeps increasing. Okay, that's the idea. As you keep increasing the input difference, the output keeps increasing. But at some point, at a particular point, you're going to hit a particular point where the output kind of levels off. That's called a positive saturation region. Okay, and then, oops, that's called a positive saturation region. And then on the other side, there is a negative saturation region as well. But you want to operate your operational amplifier in linear region as much as possible. Okay, so that's the idea of positive saturation, negative saturation, and linear region of operation. Okay, everybody with me? I'm going to go back and simply clear up all of this. Okay, but pay attention to the fact that OpAmp has 3 regions of operation. Positive saturation is where the output is plus VCC. Negative saturation, where the OpAmp output is negative VCC. And the linear region of operation, this is where you want to operate most of the time. Okay.